Good evening, everyone.
Good evening, ma'am.
Am I audible clearly?
Yes, ma'am.
Yes.
Okay. So today we will solve some questions based on limit of a sequence. So you guys learn about limits, right?
Yes, ma'am.
Okay. So these are just only facts. I will just recall that if we have a sequence, then we say that a sequence. If we have a sequence an, and so if we have a sequence an and we say that this an converges to a, or the an tends to a, if our term an gets more closer and closer to a as our n goes to infinity. That is what written in these things, that an is said to have a limit a if the numbers an comes closer and closer to a as n increases. Second thing is that an has a limit, then the sequence is said to be convergent sequence. We have a term called, what do you mean by a convergent sequence? So if a sequence has a limit, we say that it is a convergent sequence. Now there are basic arithmetical rules which we apply on limit. So here first we will assume that we have two sequences an and bn, and an converges to a and bn converges to b. Then their sum will converges to sum of the limits. That means an plus bn with whatever the new sequence will be, that will converges to a plus b. Similarly, scalar multiple of the sequence will converges to scalar multiple of the limit. That is c of an converges to c of a. Similarly, an minus bn will converges to a minus b. An into bn will converges to ab. Here f is any polynomial function, because polynomial is what? So it is made of this product and the summation, right? So if f is your any polynomial, then f of an will converges to f of a. Similarly, quotient, but here we have to uh, make sure that our bn is also not equals to 0, because if bn will be 0, then an by bn will not be defined. So if an converges to a and bn converges to b, then their quotient an by bn will converges to a by b. So this is another fact. Now this is something like exponential functions, c to the power an. So if an converges to a, then c to the power an converges to c to the power a for any real number c, where c to the power an is a real number for n belongs to a natural number, because obviously an belongs to a real number, and c is again your real number. So c to the power an is again a real number, right? Okay. Now similarly, log of an will converges to log base c of a, where an is strictly greater than 0, because then only our log function will well define. Okay. And your a and c also should strictly greater than 0, for the same reason that you want to define a log function. Now here's somewhat called sandwich rule. If you have an and bn, if cn converges to a, if an is less than equal to cn is less than equal to bn for all n. This is not true in general. Here's something, the sandwich rule tells something else, that if we have an converges to a and bn will also converges to the same limit, and if we have some another sequence cn in such a way that an is less than equal to cn is less than equal to bn, then we can say that our new sequence cn will also converges to a. Okay, so this is also known as sandwich rule. So these facts are clear to everyone. Should we move forward? Am I audible?
Yes, ma'am.
Okay. So these are important, because when you want to find a limit, there are some limits you already know, and whatever limit you have to find, you just have to look at what form, in which form it is given to us. It is some polynomial form or some multiplication or subtraction. You can apply any of these rules or not. So now we'll do some questions. So this is your first question. So try to solve it. I'll give you 5 minutes. I don't think it will take more than that. Okay. Try to solve and then we will discuss it. If you get the answer, please write in the chat box. Okay, so we'll discuss it now. So just answer these questions. If I'll ask you what is limit x goes to a of x is equals to, what will be your answer? Limit x goes to a of x is equals to what? Yeah, correct, a, right? And similarly, if I'll ask that limit x goes to a of c of x, then what is the answer?
Yeah.
C, right?
Right.
So if you observe any polynomial px, so any polynomial is always of the form that a0 plus a1x plus a2x square plus and so on plus an x to the power n, right? So if someone asks me that what is the limit as x goes to some t of p of x, then what will I do? So I'll take it as limit x goes to t of this thing. But by the summation rule, we know that as limit x goes to t, a0 will go to a0. This a1 of x will go to a1 of t, right? Similarly, what where it goes? So it is nothing but a2 of x into x, right? So this a2, this will goes to a2 of t into t. So that means it will go to a2 of t square. So that means if you have any polynomial and someone asks you what is the limit of x goes to t of this polynomial, so the answer will be that a0 plus a1 of t plus a2 of t square plus and so on plus an of t to the power n. This fact is clear to everyone, right? Yeah. Now we will go to the quotient function. That if we have a function of the form px by qx, then what can we say about the limit? So suppose you have some quotient function. Suppose you have something px by qx type, where px and qx both are polynomial. Now, if q of a is equals to 0, then limit x goes to a, p of x by q of x, right? So what it could be? So this will goes to p of a and this will become p of q of a, right? But since we have q of a is equals to 0, this limit won't define. We are not able to find what is the limit exactly. So what happens when you have rationals function? What you will do, you will factor out all those common things which are, you will factor out all those roots from px and qx. What I mean that if you look at the first option, you can simply write it. This is x square minus 6x minus 7, right? So we can write it something like x square minus 7x plus x plus 7 minus 7 upon, similarly this is x square plus 3x plus 2, so it also can write as x square plus x plus 2x plus 2, right? So if we factor it out, what we will get? We will get x minus 7 and x minus x plus 1, right? Similarly, from the denominator, if we factor it out, what we will get? We will get x plus 1 and x plus 2, right? So here these x plus 1 and x plus 1 get cancelled, and at the end we will get x minus 7 by x plus 2. Now you can observe that as x goes to 1, this is some polynomial and it will goes to minus 1 minus 7, which is equals to minus 8. And similarly, as x goes to minus 1, this will goes to minus 1 plus 2, which is equals to plus 1. So what is the answer for this question is simply minus 8 by 1, which is equals to minus 8. So everyone got this question? That there are some times where you just put the value of the limit as it is. For example, in this question, here what we will do to find out the limit, it is simply a polynomial. So if I want to find the limit of polynomial, I just put in place of x, I will put 2. So it is 2q plus 4 2 square minus 6 into 2 minus 7, which is equals to 5, right? So this option is also correct. But in the case of whenever you get something like px by qx, first task is so first you should observe that if x goes to a, then your q of a should not be equals to 0. If your q of a is equals to 0, then what should you do? You should try to factor it out x minus a from both the denominators and from the numerators and denominator, and try to cancel it out. For example, here, if I will apply x is equals to minus 1, this will become 0, right? Because it will become minus 1 square minus 3 plus 2, which is equals to minus 3 plus 3, which is equals to 0. So that means in this case, our q of minus 1 becoming 0. So we cannot put as it is the value of x. You're getting my point, right?
Yes, ma'am.
Correct. So the correct
ma'am.
options are 1 and 3. Now, if someone asks you to evaluate the value of rational functions of the form limit x goes to a of something like px by qx, where px and qx are polynomial. So what is your first steps? Your first step is, first look out that q of a is equals to 0 or not. If your q of a is not equals to 0, just put the values as it is in the given function and you will get your limit. But if your q of a is equals to 0, if q of a is not equals to 0, your limit will be simply p of a by q of a. Now, if your q of a is equals to 0, then you should try to factor out x minus a from both numerators plus as well as denominators. That means you should get something in place of q of x, something r of x, in such a way that r of a is not equals to 0. And if you are not able to find that, that means the limit won't exist. Okay. So this is a basic rule for finding the limit of any rational function. So any doubt in this thing? No? Now I'll go to second question. So this is just an answer that first we observe that this will become 0 at x is equals to minus 1. So we'll try to factor out x plus 1. So it turns out that we can cancel out x plus 1 from both numerator and as well as denominator. So we'll get something like simpler. So this is your rx, right? So you observe that r of minus 1 is what? So it is minus 1 plus 2, which is equals to plus 1. So it is not equals to 0. So that means I can put the value of x and get our limit. So this is the solution of the question. Now I'll go to second question. So this is your second question. Try to solve it. I'll give you 10 minutes. Then we'll discuss. Okay, so we'll discuss it. Anyone wants any time? So whenever some graph is given to you and they ask questions about limit, what you will do, you will try to trace this graph from the left hand side as well as from the right hand side where it goes. It's something like this, you can suppose it as a road and you are driving some car on it. So where you will go from, if you go from the left hand side, and where at which point you will reach if you go from the right hand side, left hand direction and right hand direction, where you will go. Okay, so this graph is given to you somehow. Okay, and your first option says that limit of function as x tends to 0 is 1. So what you will do, so it's saying that x goes to 0, so this is x is equals to 0, right? Okay, so what we will do, we will trace this graph from the right hand side and we will try to see where it reach, where we will end up in the y-axis when we reach at x is equals to 0. Okay, so if you travel through this graph, you can observe that we'll go through this thing, and from the right hand side, if I'll reach at x is equals to 0, this point is nothing but y is equals to 0 also. So that is, if I go from the right hand side at x goes to 0, from the right hand side you will denote it by the plus sign, so it will become 0, right? And similarly, if we travel from the left hand side also, we observe that actually at the end we will end up at y is equals to 0 itself. So that means as x goes to 0 minus, it will also gives us the 0. So that means no matter in which direction, in from which direction we are coming to that point x is equals to 0, we are ending up at the same location at the same point. So that means at x is equals to 0, the right hand limit and the left hand limit are same. So that means at x is equals to 0, our limit will exist and the value of limit is nothing but where we end up at the end. Okay, so what is the limit? So limit will be 0. So that is answer is, as x goes to 0, the limit will be 0. Okay, so what does first option says? First option says that the limit of a function as x tends to 0 is 1, which is not true. We observe that as x goes to 1, we are going at 0, not 1, right? So this option is not true. Now second option says that limit of function as x tends to 0 is 0. So this is correct, right? Third option says that limit of function as x tends to 0 is undefined. Now, what do you mean by undefined? So suppose in this case, if our graph is something like given like this and like this. So now this is your new graph. Suppose this is your new graph. Okay. So in this graph, if I'll move from the right hand direction at x is equals to 0, I will end up at this point, which is, suppose this is 0 0.07, 0.7. And from the from the left hand direction, if I'll try to move, where I will end up at 0.4. So that means if I come from the left hand direction and if I come from the right hand direction, my places will be different, right? So this meaning that your right hand limit and the left hand limit are not equal. So in this case, we say that our limit is undefined, but this is not happening at 0, right? At 0, if we move from the left hand direction or in the right hand direction, we are ending up with the same position, which is 0. At the same point, we are getting closer and closer, which is 0. Okay, so that means this option is also not true. Now, fourth option says that there is a unique tangent at a point x is equals to pi, but not at a point x is equals to minus pi. But here, if you observe that at x is equals to minus pi, our function is behaving nicely. When we don't have unique tangents, if our graph is something like this, pointed, if we have at x is equals to something, suppose at x is equals to a, our graph will look like this, some pointed shape. Then in this case, we can see that this is also work as a tangent, this is also work as a tangent, this is also work as a tangent. But here what happening, our graph is moving, our graph is turning very nicely. There is no some point or some cone type shape is happening, right? So at here, at this point, we will have a unique tangent. So this is the one scenario when we get when we have more than one tangents or we don't have unique tangents. The other scenario is something like this. If you have function, suppose my function is ending here and then starting from here and here. So here also you can observe that this will work as a tangent, this will work as a tangent, right? So in these two scenarios, you are not able to get the unique tangent. But here observe that on the both of the points at x is equals to pi and at x is equals to minus pi, our graph is behaving very nicely. So you can say that at x is equals to minus pi and at x is equals to pi, we have unique tangents. So that means this option is also not true. Okay. Now, fifth option says that there is a unique tangent at x is equals to pi as well as x is equals to minus pi, which is true, right? Okay. Now, the given function is monotonically increasing in the interval minus 0.5 pi, comma 0.5 pi. Okay. So, where is our point? Minus, this is our point, right? So, first observe this section. So, in this section, you observe that when we reach to 0, our function is decreasing, right? And and as we move far from 0, our function is increasing. So that means in the whole interval, neither our function is decreasing nor increasing in the whole interval. So that means in the whole interval minus 5 to 5, our function is not decreasing. Our function is neither decreasing nor increasing. So that's why this option is also not true. Now, last option says that the given function is monotonically decreasing in the interval, but as we observe that in the interval, our function is neither decreasing nor increasing, because from minus 0.5 to 0, it is decreasing, and 0 to 0.5, it is increasing. So that's why this option is also not true. So the answer are this, 2 and 5. So any doubt? No doubts?
No, ma'am.
So whenever you have given some graph, just try to move from the left direction and try to move from the right direction, and observe that where you will end at the end of the point. For example, if I'll ask what is the limit of this point, so from the left direction we will get 1, and similarly from the right direction also we will get 1. So that means the limit is 1. So something like that you can remember. So the correct options are 2 and 5, right? Now here's your third question. So we'll discuss it by one. So just try to answer for option number 1. I'll give you 3 minutes. Just answer for option number 1. And these are the hints for you. These are the hints. And use these rules, whatever rules we have discussed from 1 to 9. The limit of addition, limit of subtraction, what it will be. Try to break it down into these functions and then apply the limit. You can get your answers. This answer for option number 1. Okay. So in this limit, you somehow get intention that, okay, in the numerator we have log of 1 plus x, and we have given this limit that log of 1 plus x upon x is equals to 1. So what I'll do, so I'll write this limit as x tends to 0, log of 1 plus x upon x, that I know, into sine x. But if I want x in the denominator, what I have to, what should I do? I should also multiply by x also. That same thing, that multiply and divide by x. Okay. So now here you have some intention you get. Okay, sine x by x, we have something like x by sine x. So what we will do, so we will try to split them up. So it will become that this is log of 1 plus x by x, and this will become sine of x by x, right? Now this is something like an by bn case, where we know that what is the limit of this term, and we also know what is the limit of this term separately. Now we want to find what is the limit of their quotient. Okay, so it is simply the limit as x goes to 0. This is 0. So log of 1 plus x by x upon limit x goes to 0, sine x by x. And this is nothing but 1. Now here there is 2 in multiplication. So limit will be 2 into 1, which is 2. So that means this option is correct. The second option is similar to this, because the limit is undefined. So no, limit is well defined and the limit is so. So that's why this option is not correct. Now answer option number 3 and 4. Okay. So here what we have something sine of 3x by x. So, but here we have x by x, and also our x is going to 0. So I should manage to create in terms of x. I can also write this is same as that limit 3x going to 0, sine of 3x upon 3x. This is also equals to 1, right? So try to modify this term into something like sine of 3x by 3x. So what we'll do is just multiply by 3 and divide by 3. So you'll get sine 3x by 3x. Now observe that if your x is going to 0, your 3x will also goes to 0. So that means limit 3x tends to 0 we can apply. So that means limit 3x tends to 0, sine of 3x by 3x into 3. So this will limit become 1, and this is multiple of 3, so it will become 3. So that means the answer is not 1, so it is not true. Limit x goes to 0, sine 3x by x is given to us. Yeah. So that means the fourth option is correct, right? 3 is incorrect. Wrong, right? So any doubt till now?
No, ma'am.
Now fifth option is also similar. We just multiply and divide by 5. So what will happen here? So this is something sine of 5x by x. So this will become 5 multiple, 5 divide and 5 multiple, and this limit will become 1. So our answer is 1 into 5, which is 5, but it is 1 by 5. So that means it is not. Okay. Now try to answer these. Okay, so they have the same limit. Try to find the limit. What is the limit for these 4 options? Use this thing. Now you have this hint that limit x goes to 0. Audible? So you have this thing that limit x goes to 0, e to the power x minus 1 upon x is equals to 1. So we can simply replace x by x to x by 5. Then since x goes to 0, x by 5 will also go to 0. So that means x by 5 will also go to 0. And we have e to the power x by 5 minus 1 upon x by 5 is equals to 1. So this is something we have. This is given to us. So then what will happen? So here we observe that, okay, it is something like e to the power x by 5 minus 1. So which is same as this, this numerator, right? So what I'll do, so I'll try to simplify, I try to break it down so that I will get the limit which, so I will get the limit in terms of some limits which I already know. So it is something e to the power x by 5 minus 1 upon sine of 5x. Okay. So what I'll do, so here I observe that this is x by 5 is in the denominator. So I'll multiply and divide by x by 5. So that means first I'll do that multiply and divide by x. So this will become x into x upon sine of 5x. Now here observe that if I'll multiply it by 5 and 5, multiply and divide by 5, this term, this limit will go to 1. But not this term, because here I want x by 5. What I am getting 5x. So it is not same as this thing. So that means now we have to further reduce it. So it is e to the power x by 5 minus 1 upon I want to x by 5. So that means again in the denominator I am multiplying and dividing by 5. So there is again a 5 here. So I am dividing by 5 and multiplying by 5, right? So this term will again leave as it is. So it is sine 5x. So then 1 by 25 will come out. This is this 5 and this 5. And I'll get e to the power x by 5 minus 1 upon x by 5 and into 5x upon sine of 5x. Now this is something I already know, that the limit of this function will be 1 and the limit of this function will be 1. So what is our answer? So our answer will be 1 by 25. So that means the option 8 is true. All others are not. Okay. So any doubt so far? Okay. Nothing conceptual happened till now. We are just doing simple examples based on limit. So that means our option 1, 4 and 8 are correct. So yeah, 1, 4 and 8 are correct. Okay. So limit of some standard function are given. So I advise you to note down these limits. That these limits are not that trivial to prove that it will exist and it is equals to 1. So for this course, you should you should remember that what is the limit of x tends to 0, sine x by x is equals to 1. So just wrote it down and try to remember it. Similarly, these limits are also not that trivial to prove, not that trivial to show that it will exist and it turns out to be 1 or whatever the values are given. So I'll suggest that you should remember it, so that it will be helpful to find out the limit of other functions. Okay.
Can you do the previous slide?
Yeah. This one.
Yes.
It is not that trivial to show that this limit will exist and it will turn out to be this thing. It requires some more tools. It's okay. So now this is your, yes.
Yes, ma'am.
Ma'am, second set here. Yeah, second set of that. Thank you.
What?
No, ma'am, that's it. This screenshot in there.
So use these limit. The concept is still same, that you should reduce your given function in form of these limits so that you can apply your limit in terms of addition, multiplication, scalar multiplication, something like that. So try to solve it. I'll give you 5 minutes, 10 minutes. 9. Okay, so we'll discuss it now. So this is our function. We have to find the limit of this function. Now it looked like so horrible that so many terms are involved. So, but at the back of our mind, we should always remember these limits. First limit is limit x goes to 0 of log of 1 plus x upon x will be equals to 1. Similarly, limit x goes to 0 e to the power x minus 1 upon x is equals to 1. Limit x goes to infinity. Now here observe that this limit is going to 0 and this limit is going to infinity. So keep in mind that these are not same. By x upon x factorial to the power 1 by x, this is equals to e, and the limit x going to infinity of x by the x root of x factorial, this is equals to e. Okay, so these are the limit. So in the given function, try to reduce your terms in these form of limit. So first is e to the power n. Sorry, it's not e to the power n, it's the nth. So e is a constant, so we'll leave it as it is. Now we have this thing. So for now, this focus on the bracket terms, that what we can do. Okay, so this is log of 1 plus 6 by n. So I have something log of 1 plus x by x. So I'll try to reduce in this form. So this will become log of 1 plus 6 by n. Now I will multiply and divide by 6 by n. So this is 6 by n. Now here it will become 6 by n. I mean, in the numerator, it will become 6 by n, which is same as, you can write as at 6 and then by n, right? Okay. So this is one term, we can solve it. Now this is e to the power minus 1 by n minus 1. Now again, I have e to the power x minus 1 upon x. So here x is 1 by n. So I will multiply and divide by 1 by n. So what will become? Here I have to add 1 by n also. Okay. So this term is done. This term is done. Now what you can say, what you can think about this term. Okay. So this is in the denominator of this one. Okay, don't get confused. So so I have something more complicated, that under the root of 2 pi x and upon x factorial and the whole power 1 by x. So what I'll do? So I'll under the root of 2 pi of n upon I'll do n factorial, and this has to the power 1 by n. So again I will multiply and divide by n factorial to the power 1 by n. So again I have to multiply by n factorial to the power 1 by n. So this is the simplification I am able to do till now. Okay. So now observe this term. So this is what. So if I will pull my limit inside, so what will happen to limit n tending to infinity of log of 1 plus 6 by n upon 6 by n. Right? Okay. But what I have limit x goes to 0, not x goes to infinity. So what I'll do, so I'll replace 6 by n to x. So then as my n goes to infinity, what will be the value of in terms of n? The value will be this. This will come here. So this will 1 by n is equals to x by 6. So that means n is equals to 6 by 6. Right? Okay. So but observe that as your n goes to infinity, our x will goes to 0. Because x is what? 6 by n. So n is going to infinity. So this will become 6 by infinity, something you can observe. So that means this is nothing but 0. So this limit will turn out to be limit x goes to 0 log of 1 plus x upon x, right? And we know that this limit is nothing but 1. So we have solved this term. That this will become 1 if we pull our limit inside the bracket. Okay. And we'll remain with 6 by n. Okay, fine. So one thing is done. Now similarly, we will look for other terms also. Yeah, maybe similar question you will see in the graded assignment. That's true.
Ma'am, can you explain this last part where you flipped over 6 by n?
Yeah. So what I was saying, that I want to find that limit n goes to infinity of log of 1 plus 6 by n upon 6 by n. But what I have that limit x goes to infinity of x goes to 0 of log of 1 plus x by x. This is equals to 1.
Right.
That I have. So I
Right.
want to somehow convert this limit, this n goes to infinity, to something goes to 0. So you observe
Right.
that if you take your x to be 6 by n, then as n will goes to infinity, your 6 by n will go to 0, right?
Right.
So that means your x will go to 0. So if you replace your 6 by n to x, then this limit will convert to that limit x goes to 0 of log of 1 plus x upon x. And we know that this is equals to 1, right?
Right. Okay.
Correct. So we done with the one term. Now we go to this term. So similar logic will apply here also. That we have limit n tending to infinity of e to the power 1 by n minus 1 by 1 by n. So similarly, if I'll replace my 1 by n to x, then we know that as our n goes to infinity, our x will go to 0. Because what is our x? Our x is nothing but 1 by n. So it will go to 0. So that means this limit will also convert into that limit x goes to 0 of e to the power x minus 1 by x. And we know that this is equals to 1 again, right? So we have done with this, this term. This will become 1. And similarly, this term will also become 1. Now we'll just go to the terms which are in the denominator. So in the denominator, what I have? So in the denominator, we have something like under the root of 2n pi upon n factorial. This has to the power 1 by n, and this also has to the power 1 by n. But what I know, so I know that limit x goes to infinity under the root of 2 pi x by x factorial to the whole power 1 by x. And also I have some multiplication of x here, right? Yeah, this is some x into under the root of 2 pi x upon x factorial to the whole power 1 by x, right? So I have to convert it into something like that, something like this. Okay, so what I'll do, so this is this is same as under the root of 2 pi n upon n factorial to the whole power 1 by n. Now I want n in the numerator as well as in the denominator. So I will multiply and divide by 1 by n. So here also what I'll do, so I'll multiply by n and I'll divide by n. It becomes a little messy, but okay, fine. I'll write it again. Okay. So now, if I'll apply, now what happened? Now in this term here you cannot apply limit x goes to infinity. Why? Because then this term will go to e, but your 1 by n, this will go to 0, right? Right now. So what we'll do, so we'll try to look this in the whole bracket so that our there is possibility that our n maybe get cancelled. Okay, so I'll write it again. So start with this thing. It turns out that this is nothing but limit n tending to infinity of e of the nth root to the power n into this will become our log of 1 plus 6 by n by 6 by n into 6 by n, right? This term is we have sorted out. It will become that e to the power minus 1 by n minus 1 by 1 by n, and upon this is again into 1 by n. This multiply and divide by 1 by n, right? Okay. Now upon we have what we will get under the root of 2n pi upon n factorial to the power 1 by n into n factorial to the power 1 by n. This we have done. Now what we'll do, what we have done, that we'll multiply by n here and we'll divide by n here also, right? But it turns out you can observe that here we have something like 1 by n, and here also we have something like 1 by n. So this and this will get cancelled out, right? Okay. So we have that limit n tending to infinity e. This is n factorial by n. This will become as it is. Now it is minus 1. And I have that limit of 1 by n minus 1 by 1 by n upon this is n into under the root of 2 pi n upon n factorial to the whole power 1 by n into. Now what will remain here? This this 1 by n, then 1 by n cancel out. This will remain here. That is nothing in fact.
Ma'am, in the first term, 6 by n would remain, right?
Yeah. This is as it is. This is as it is. Yeah, 6 by n will remain. So I'll apply limit n tending to infinity. But since I haven't done what will happen to this term now, right? So that also I should take it in mind. So now we will bring this term inside the bracket and try to adjust it. Okay. So what will happen? So it is limit n tending to infinity. E will be there. And this is again log of 1 plus 6 by n upon 6 by n into 6 by n multiplied by, this will become nth root of n factorial, right? But for nth root of n factorial, what we have this thing, right? That x upon the x root of x factorial. This is same as n upon the nth root of n factorial. So we'll try to modify this term also. So what can I do? That I'll bring this this term, this in the denominator. So it will become, so that means I'll take it here. So then it will become n upon nth root of n factorial, right? So it will remain as it is. And now I can think about, okay, fine. This we have limit for this term, right? And we also have limit for this term. Then we can apply. Okay. Now this minus n will remain as it is. So e to the power 1 by n minus 1 upon 1 by n. Okay. Now I am multiplying by n this number, right? And same thing I have here. This is nothing but n factorial by n factorial. So this and this will get cancelled out. So it will become, so it will just have under the root of 2 pi n upon n factorial to the whole power 1 by n. So at the end, we get this term. So everyone is agree or there's some confusion? No?
Ma'am, can you
Hello.
please
Excuse me,
repeat
ma'am.
again?
Ma'am,
Yes.
ma'am, can you please provide the solutions of graded and practice assignment onwards week 4?
Onwards, week 4. Okay,
Because
fine, we'll provide.
in my dashboard
You
it was
mean
not
detailed solution, step-by-step solution?
Yeah, ma'am. Because I have seen week 1 to week 4 solutions are there of graded and practice, but after week 4 it was not there in dashboard.
Okay. So we'll provide. I'll note it down.
And CT also it was not there, ma'am. Can you please CT and maths?
Okay. Yeah, I will tell them to put. They haven't given this step-by-step solution till yet. I mean, it's week 7 now. Okay, fine. So there is no doubt in this question now. Okay, so now what we'll do? So we'll push our limit inside the bracket. So it will become e here. This limit will become 1 into this will become 6, and the above this denominator limit, this n by the nth root, this will also become 1. And what we'll get minus, sorry, it's not 1, I guess it's e. Yeah, so this is e, not 1. Okay, and then minus this limit is also turn out to be 1, and this limit will turn out to be e, right? So what is our final answer? So our final answer will be e bracket of 6 by e minus 1 by e, which is nothing but 5. Okay. So there is nothing more. I mean, this is just a lengthy calculation. You just have to go through step by step. This is the precise solution. If you want to take screenshot, you can take it. Okay. I'll go to next question. Question number 5.
Ma'am, 1 minute, I have to text.
Yeah.
Ma'am,
Okay, ma'am.
will in the quiz and term, will we have similar question with a similar rigor?
Yeah, you can. I mean, you can hope for the similar questions. Yeah, there will be similar questions. I mean, the questions are not that much tough as they are put it in the graded assignment. It will be simpler than that, but you can assume up to practice assignment questions, the level will be the same.
Okay.
Done, ma'am.
So now this is the next question. So I'll give 5 minutes because it's not that tough, okay? So just read and answer it. 9:25. 7 minutes. This is exactly same or there is some modification? Because I think there is some modification in the sequence. Adarsh,
Yes, no modification. Exactly same AN, BN, and CN.
exactly same. Okay.
Yeah, exactly. By number and by sign, both.
Okay. So, what is the last
Like
date for
options
submitting
given.
the week 7 graded assignment?
Yeah,
What is the last date for submitting the
it is tomorrow.
tomorrow?
It is tomorrow. Yeah.
Actually, I also don't know. The slides are given by someone else. So So okay, fine.
Yeah, okay.
So what is the question? Question says that suppose a company runs 3 algorithms to estimate its future growth. Suppose the error in the estimation depends on the variable number n of the data as follows. So these three sequence actually gives the estimation for error in the 3 algorithm. If you run the first algorithm, this will be the estimate error which can happen, and similarly bn and cn. Now here it says that your n will belong to natural number minus 0, and suppose the company has a large amount of data in hand, so that means we can assume that our n is too large, so that means we can assume our n goes to infinity also, that means n tends to infinity also. So using the information given above, answer the questions which of the following statement is are correct. Okay, so first option says that the error in the estimation by algorithm 1 will give the maximum error. Okay, so what we need to find, we just need to find what is the limit as n goes to infinity of sequence an, bn and cn, because as you know, at n is equals to 5, your a5 will estimate the error, right? So as your n will go larger and larger, your an will should tend to something, and that will be your estimation, right? So what we'll do, we'll just compute the limit of these three sequences as our n goes to infinity. So first we will compute that what is the limit of n goes to infinity of an. So it is what? So it is limit n goes to infinity of n square plus 5n upon 6n square plus 1. So you know how to solve it. What we'll do, so we don't we have here something like infinity by infinity case. So what I will do, so I will take common what is the highest power of n, and then I will apply the limit. So it is same as limit n goes to infinity. So I will take out n square from here, so it will become 1 plus 5 by n. 5 by n. And similarly n square from here, so it will become 6 plus 1 by n square. Okay, now n square and n square get cancelled out. It will become that limit n goes to infinity of 1 plus 5 by n upon 6 plus 1 by n square. Now we know that these terms will go to 0 as n goes to infinity, right? So these both term will go to 0 as n goes to infinity. So what is our required answer then? It is 1 by 6, because this will become that 1 plus 0 by 6 plus 0. So the answer is 1 by 6. So this is the error estimation for first algorithm. So first algorithm, what we'll get? 1 by 6. Okay. Now similarly proceed for the second algorithm. So it is limit n goes to infinity of bn. So that means we have limit n goes to infinity of that it is 1 by 8 and then plus minus 1 to the power n of 1 by n. So as we know that as n goes to infinity, minus 1 to the power n by n, this will reach out to be 0, right? Because n goes to infinity, again we have minus 1 by 2 and 1 by 2. Then we have minus 1 by 3, 1 by 3. So again we come closer and closer, closer and closer to 0. So that means the limit of this function will be 0. And this is a constant function, so it won't affect. So in this case, what is the limit we'll get? So we'll get 1 by 8. So the second is 1 by 8. So you guys are following, right? Till now you have any doubt?
Yes, ma'am.
Okay.
No, ma'am.
No, it's clear.
So now same thing we have to do for Cn also. So Cn, observe that you have e to the power n plus 4 by 7 into e to the power n. So limit n tending to infinity of e to the power n plus 4 by 7 into e to the power n. Here also you get some intention. Okay, fine. It is something like infinity by infinity case. Okay. So what I'll do, so I will take common what is the maximum term which is cause of for infinity. So here you observe that e to the power n is the main cause for infinity, right? So we'll take out e to the power n. So it will become limit n tending to infinity. It will become 1 plus 4 by e to the power n, right? And here we will get 7. Now, as we apply limit n tending to infinity, this is a constant, so it won't get affected. But this term, since as n goes to infinity, e to the power n will go to infinity, but 4 by e to the power n will tend to 0. So here, in this case, we have the answer is 1 by 7. So it's 1 by 7, right? Now you know that 1 by 8 is less than 1 by 7 is less than 1 by 6. And this is the error estimation for Bn, error estimation for Cn, and this is the error estimation for An. So what is our options? Options is that error estimation by algorithm 1 will give the maximum error. Correct. 1 by 6 is the maximum quantity. So this option is correct. So error in estimation by algorithm 3 will give the minimum error. No, will the error in estimation by algorithm 3 is given by 1 by 7, which is not the minimum. Minimum is 1 by 8. So that's why this option is not true. Both algorithm 1 and 2 will give the same error, and that will be the maximum. This is also not true, because the error given by algorithm 1 is 1 by 6 and the error given by algorithm 2 is 1 by 8. These are not same and these are not even maximum. Okay. Error in estimation by algorithm will be 0.1666 approximately. So you can calculate what is, okay, so 1 by 6 will be 0.16. Yeah, right. So this option is 2, right? And error and for second algorithm Bn, what we have 1 by 8. So 1 by 8 is again 0.1.
2.
What it would be? 2.
What?
Yeah, this is also 2, right?
Right.
Yeah, fine. So it's easy question. You just have to, whenever you get these kind of things, and you have to ask that you have asked that evaluate the limit as n goes to infinity, try to factor it. I mean, try to pull the most what is the highest power of n, and then cancel it out, and then you can easily estimate. Similarly, here also we did that e to the power n is the cause for infinity by infinity. So I will pull e to the power n outside, try to cancel it out and estimate it. So these are the basic ideas you should note it down. Okay. So any doubt in this question so far? No. So this is the precise answer. So we have done with all those questions. So any doubt on the concept of limit or something else, because we have time now, or anything? Anyone want to discuss some another questions? This PDF, which PDF? This PDF I will upload in the chat box at the end of the class. So how's your course is going so far? Yes.
Yeah, it's nice. I two experiments,
Your voice is breaking.
taken. Hello.
Yes.
Hello. Are you clear?
You are not audible. I mean,
Uh, is my voice is clear now?
yeah.
Screenshots out of the lecture. Can you
Uh,
explain the paragraph
Is your voice
written
not audible right
in
now?
chat?
yeah, actually, you are not well audible. You can message in the chat box. Bharat, you can share your question in chat box or screenshot of that question so we can discuss it. Oh. There is some girl, Karishma. Karishma is present.
Ma'am, can we go over some sequence problems, sequence and series problem? How to solve?
Series. I think you haven't discussed series yet, but yeah, we can go for sequence problems. What type of sequence problem? Some convergence type problem or something?
In the graded assignment, there is one question which is about series, ma'am. So
There's question about series.
yeah. So if we can discuss on that topic, at least I can attempt that question.
Okay. This question is similar to the question we have did. Bharat, you have asked this question. Na? Just try to reduce these terms into the form of limit n by n factorial to the power 1 by n. You'll get your answer. Because as n tends to infinity, 2n plus 1 also tends to infinity. So your first term will reduce in some sense, right? So first term is nothing but the e. And similarly, the second term is also nothing but e. So the answer should be, I guess, 2e or what? Right? Yeah, it is a similar question. Yeah, about the sequence and series. Okay. Actually, it is a so large topic. I mean, what type of question they have asked in the graded assignment? You can tell me so that I'll move around that question. I won't give the exact answer, but I will somehow recall your theory part so that you know.
Let me go to graded assignment. So they have given a series sequence given by an equals to 12 plus 20 plus 28 plus up to 8n minus 4 by n square, and they want to find the limit for this one.
Want to find the limit for this sequence? Yeah. Okay. Okay.
But sequence would be comma delimited, right, ma'am?
Sequence.
Like it would be like 1, comma 2, comma 3, comma 4, comma 5.
No,
Right? If we take 1
this is
plus 2
not
plus
always the case.
4,
Yeah, this is not always the case. For example, if I'll give you sequence where your A1 is 1, my A2 is 1 plus 1 by 2, my 3 is 1 plus 1 by 2 plus 1
yeah,
by
but still there would be separate terms, right? A1, comma A2, comma A3,
yeah,
right?
yeah,
But if we are talking about A1 plus A2 plus A3, then we are talking about series, not sequence.
yeah. So from that series, you can extract a sequence. For example,
Right, right, right. So this question is about a sequence.
yeah.
Sorry,
So
it's about a series, not a sequence, right? Because it
yeah.
says
Suppose you have some series summation a n type, right? This is something given to you, right?
mhm.
So this is something like a naught plus a1 plus a2 plus and so on, right? So what you can do for this series, you can construct a sequence Sn such a way that your S1, your S naught will be a naught, your S1 will be a naught plus a1, your S2 will be a naught plus a1 plus a2, and similar way, your Sn will be a naught plus a1 plus a2 plus and so on plus an. Now you agree that this is a sequence Sn, right?
Right.
Now what happened that if your Sn converges to S, then your limit summation an will also converge to S.
Mhm.
Yeah, it's like a sequence of partial sums
Yeah,
of n
sequence.
series.
Yeah, same topic.
Yeah.
So if in the assignment, if you have given the something series, so try to break it down into this sequence and then try to find where does the limit goes. You're getting my point?
Trying to think through. Uh,
Yeah, it's tough. I know that question is also tough, but fine.
Yeah, just make little changes and you will get the pattern.
Okay. So you have given you hint.
Sorry. Okay, ma'am, I have posted the question.
This screenshot of slide. I mean, what is your
Yes, yes. So in the slide, let me see it. Yeah, here the caption given. So the idea that tangent line intersects the curve in only that point is not correct. So how? I don't get it. Like there is the paragraph. Often the tangent line to the curve. So this paragraph is not clear.
Okay.
Because for a straight line we get the tangent line and the intersecting line
The same.
like yeah in
Yeah.
the case same that the tangent line is the one of the intersecting lines
Yeah.
of that line.
Correct.
Yeah, so that's I don't, so this line what it means in general sense.
Tangent line intersect the curve is the only that point is not correct. Yeah, this is same logic as you have, that if you have some straight line, suppose you have this straight line y is equals to x, right? So if I'll say that find the tangent line at x is equals to 1, what is your answer? This itself is a tangent line, right?
Itself, yes.
And this tangent line this tangent line will pass through every other point of this line, right?
Yeah, right.
So something like that, or you can observe this graph also. This is a graph of mod of x.
Yeah.
So at 0, if I'll draw this line also passes through one line, right? One point at the graph.
Yeah.
So this should be a tangent, right?
Yes, but it is not.
But it is not, because here the tangent is not even.
The idea of direction fails.
Yeah.
Tangent.
So tangent is basically gives you the slope of the curve, or in which direction the curve is moving. So that is the main objective of tangent line, irrespective of it just touches the graph at one point.
Yeah.
Right.
So one graph. If we are given the one graph, and so in net cell the tangent line is with respect to the point, not the curve.
Tangent line with respect to point, but it also depend on the curve. For example, if you have this curve and if you have this point, right? So here your tangent line will be something like that. But if
Yeah.
you have this some different curve, but your point will be the same. So the tangent line will be of this point, but the direction will reverse in that case. So that means the tangent line somehow depend on a point, but it also somehow depend on a curve. That's the point. I mean, it is not irrespective of curve, independent of curve, you can say.
Okay. Like if we consider the graph of the function 1 by x.
1 by
So
x.
here, yeah. So for 1 by x, we cannot find the, can we find the tangent at as x equals to 0 at x
No,
equals to
because
0?
the function itself is not even defined at x is equals to 0.
Yes, yes,
Right.
that's my point.
Yeah.
So so even so, okay, I am missing the two concepts. Okay, fine, thank you.
Any other doubt? Any question? That series question, try to solve it, or you can search on the, I mean, internet, you will get lots of answers.
Yeah, but one question about 1 by x. So here, y axis, it is also a tangent, like asymptotes.
Yeah, it is asymptote, not tangent. Tangent and asymptote have different meaning, right? This is
which supposed to touches. Okay, it is not.
Yeah, it
asymptote
has to
never
touch, right?
touches the graph. It
Yeah,
will go
it's supposed
parallel.
to touch. Yeah,
Sorry, what?
but it's supposed to touch, but at infinity, but not
Yeah,
exactly touches.
it won't touch. Supposed to touch. Yeah, you can say.
Yeah. Okay. Okay. Now clear.
So that graded assignment thing, that graded assignment is too tough. So what? So we come up with a solution that we will try to discuss similar questions in the solve with us sessions. So I don't know, they just put the exact same question, but that's our motive for solve with us, that we will try to do the similar kind of questions which are present in the graded assignment, so that we don't have to change the graded assignment also, and you have some idea to do it. Okay, you can pursue PG on behalf of this degree or any entrance. That I don't know actually. I mean, you can pursue or not, but I think it will give you some bachelor degree. So in base of bachelor degree, 3-year bachelor degree more precisely. So whatever you can pursue. So don't have any questions. So I'll try to find some questions.
Ma'am,
Yes.
can you explain some standard limits in brief? Like some limits that tends to E, like those are them.
I mean, there are some. There are some
I don't
standard
understand.
limit n tending to infinity of 1 plus x by n to the power 1 by n, right? This goes to e to the power x. It's 1 by n or
Yeah,
n?
these kind of things. Yeah.
N or 1 by n? Getting confused.
Oh no, it would be 1 by sorry e power n.
No, this is x, so it is e to the power x. But I'm asking, it is 1 plus
Oh,
x by n to the power 1 by n or n? I think it is n.
it is n.
Yeah. So these limit is, I mean, tough to prove. I mean, we have to use some other algorithm, some test, some limit test, or some epsilon delta things, or something else we have to use to prove that this limit will exist and it is same as e to the power x. But what you can do for this course, you just have to remember it. Okay, just make a list of all those standard limits and then put it on wall or just remember it. Okay, so if you want the precise list, you can go to these books called calculus by Thompson or something. I will put it in the chat box. So they have given some limits which are important.
Ma'am, for current scenario, based on your experience, can you list down some important of these kind of formula?
Okay, actually I mean, there are some limit which given to you in the lectures also now. I mean, what
Yeah,
else can
given,
you
but
do?
I don't understand them. That is why I'm asking.
Yeah. So you can share the screenshot which limit you are not able to understand. Maybe then
Booking calculus.
no, it's not calculus made easy. It's Thomas calculus by Pearson's publication.
Ma'am, how are these standard limits formulated? Using calculus or
No, it
do
required
they
more
have
analysis. I mean, it is
more
not
analysis?
precisely calculus, but
Hmm.
it requires some other definitions of limit. I mean, in mathematics, limit is a very vast and very important topic. I mean, there are 4 to 5 ways to define limit. First is your this left hand limit and right hand limit. This concept which you have already learned. Second is some epsilon delta definition. Third is sequential criteria. So there are so many types of definitions of limit you you will see if you go for the higher studies, and these definition will gives the answer for those standard limits, something like that. 1 plus 1 by n or to the power n is equals to. So these limit will be derived using these definitions. Not we cannot derive it from just left hand limit is equals to right hand limit thing. Right? You just know this thing. You don't know all other criteria. So that's why I'm saying that if you find out the limit, just try to remember it that okay, fine. This is something look like this. So this should be 1. It's minus 1. This should be 1. Right? So just try to remember it. There is no other option.
Can we prove them using L'Hopital's formula?
L-hospital formula.
Yeah,
Maybe I haven't tried it.
that previous one. Limit x tends to infinity 1 plus e power x by.
Oh yeah, that I think you are able to do with L-hospital formula, because this is limit x goes to 0, e to the power x minus 1 by x.
Zero.
Because as you see that this is something like 0 by 0 form. So whenever you have 0 by 0 form or infinity by infinity form, but for applying L-hospital rule, you should know the derivative. You haven't studied till yet now. I mean, you don't know what is the derivative of e to the power x. I mean, you know, maybe, but in this course we haven't studied, right?
Yeah.
So something this type of calculation you will learn. I have sent the book by Thomas Calculus. It has some standard limit and it has some standard questions. You can go through it.
Okay, thanks. And is it necessary to be precisely 0 by 0 or infinity by
Yeah,
infinity?
yeah, it is
There are
necessary. Mean there
other,
are
yeah,
no, there are other indefinite form, that is 0 by infinity or
yeah,
infinity into infinity.
infinity
So
power
then what?
infinity.
Yeah, we have to convert it into these forms. These are the only two forms where a L-Hospital rule can apply. For other form, you have to convert it into 0 by 0 or infinity by infinity, and then you have to apply it. So that's the one thing you should remember. So if there is no other doubt, we can end the session if you guys want, or we can discuss some other questions also if you have any questions.
Ma'am, one question regarding quiz 2,
Yes.
whether we will be having a chapter from 5, 6, 7, 8, or it will be from chapter 1 to 8.
There will be one or two questions from starting, but the major part, I mean, I will tell you can expect 70% from the last chapters and
Okay.
maybe 30% or 20% from the previous weeks, 1 to 4. Because we have already evaluated on these 4 weeks, so our main target will be these remaining 4 weeks.
Okay. Thank you, ma'am.
Yeah.
Ma'am, in that case, how do we take n natural numbers? Should we consider 0 to infinity or 1 to infinity?
Okay.
Because there's a conflict, right? In the
Yeah.
first chapters, we have to assume one thing, and
Okay. And the week 7, I think Sarang sir said that it is from 1 to infinity, right?
yes,
So, so don't worry, we will precisely mention it whenever we are using natural number. It is 1 to infinity or 0 to infinity. Okay. So that we always keep in mind. So we'll precisely, for example, here it is given that this is n belongs to n minus 0, right?
right, right.
So we'll try to give it in some sense, something like this. Then here
Oh,
you can easily check that n is 1 to infinity, right?
yes.
Yeah.
Right.
Okay, then I think you guys don't have any doubts, and I also don't have any questions. So
Yeah. Thank you, ma'am.
yeah, thank you for joining.
Thanks.
Okay. Anyone wants to give any feedback about class? They can give. Yeah, yeah, I'll share the PDF.